GM just dropped a bomb on the entire truck industry, and the 2026 6.6-liter V8 is rewriting everything we thought we knew about naturally aspirated power. After analyzing the engineering data, forged internals, and real-world reliability metrics, one thing is clear: Ford and Ram have a serious problem. But here's the twist: the horsepower numbers aren't even the most impressive part. The real game changer is what GM engineered into the valve train and oiling system. By the end of this breakdown, you'll understand exactly why mechanics are calling the L8T the most over-engineered gas V8 currently in production. Let's get into it. The L8T strategy: reliability over marketing. GM's 6.6-liter L8T V8 produces 401 horsepower and 464 pound-feet of torque. On paper, that seems competitive, but not revolutionary. For comparison, Ford's 7.3-liter Godzilla delivers 430 horsepower, and Ram's 6.4-liter Hemi makes 410 horsepower. At first glance, you might assume GM is playing catch-up. Here's the critical detail: GM didn't design this engine to win a spec sheet war. They engineered it to survive 300,000 miles of commercial abuse without a single terminal failure. That focus on reliability over marketing is what sets the L8T apart. Ford and Ram might dominate peak horsepower charts, but GM focused on long-term durability, a metric that matters most in commercial and fleet environments. Why you need to subscribe: the mechanical truth. Before diving into the specifics, if you're tired of surface-level car reviews and want the mechanical truth behind these engines, hit that subscribe button. We break down the numbers, engineering, and real-world performance without marketing fluff. In just a few minutes, you'll see the oiling system modification GM borrowed from diesel architecture, a change that ensures this engine will outlast its competitors by over 100,000 miles. But first, let's examine the philosophy behind GM's design choices. The turbo trap: complexity versus reliability. The first major insight comes from understanding the turbo trap. Modern truck manufacturers, including Ford and Ram, have pursued forced induction, EcoBoost turbos, Hurricane twin turbos, chasing peak horsepower numbers to win magazine comparisons. The problem? Turbos introduce complexity, heat, and additional points of failure. For fleet managers running dozens of trucks, complexity is an enemy. GM approached the market differently. What if a naturally aspirated V8 could match the durability and longevity of a diesel engine? That's exactly what they did. The L8T's architecture includes cast iron block instead of aluminum. Heavier, yes, but far more resistant to thermal cycling over decades. Forged steel connecting rods, designed to withstand repeated high-stress cycles. Forged steel crankshaft, capable of long-term endurance under heavy towing loads. Hyper-eutectic aluminum pistons with reinforced skirts, optimized for both strength and thermal expansion control. This isn't a performance-focused engine designed for drag strips. It's a commercial-grade workhorse, engineered to run reliably for hundreds of thousands of miles. Valvetrain secrets: the cold start lockout. Next is the valve train. GM equipped the L8T with a dual overhead cam phaser system featuring variable valve timing on both intake and exhaust. Anti-cam phasers are known failure points in many engines, including Ford's EcoBoost lineup, often producing the infamous death rattle during cold starts. GM's solution? A hydraulic lockout mechanism that physically prevents phaser movement until oil pressure stabilizes. Unlike Ford's system, which relies solely on oil pressure, this mechanical lock avoids phaser rattling and subsequent wear. The result? Reduced risk of cam phaser failure, improved engine longevity, avoidance of expensive early life repairs. Additionally, GM uses dual valve springs with dampers to prevent valve float at high RPMs, a critical feature for trucks towing heavy loads. Ford's 7.3 liters uses single springs, which are lighter and cheaper, but more susceptible to float under sustained load, especially when towing heavy trailers or climbing steep grades. This focus on reliability under extreme conditions reinforces GM's philosophy: not just making power, but making power under the worst possible conditions for the longest time. The diesel-inspired oiling system. Where GM's engineering really stands out is in the oiling system. Borrowing architecture from their Duramax diesel engines, the L8T features a high-volume, high-pressure oil pump, oversized for a gas engine. This ensures that even under extreme angles like off-roading or steep inclines, the oil pickup never cavitates. Key features include fully baffled oil pan with trap doors, keeps oil near the pickup no matter the truck's angle. Integrated engine oil cooler plumbed into the coolant system, stabilizes oil temperatures during extreme towing operations in high heat. Ford's 7.3 liter has an optional oil cooler as part of a towing package, but GM made it standard, understanding that their customers won't baby these trucks. They'll use them hard. Fleet operators' early data confirms this design. Fewer failures, lower maintenance costs, and extended engine life. GM is engineering for real-world durability, not just peak numbers on a dyno sheet. The 2026 V8 landscape, GM versus Ford versus Ram. Looking at 2026, the V8 market has three distinct approaches. GM 6.6 liters L8T, naturally aspirated, built like a diesel, engineered for reliability. Ford 7.3 liter Godzilla, pushrod V8, higher peak power, simpler internals. Ram 6.4 liter Hemi, largely unchanged since 2014, facing lifter reliability issues. Fleet managers favor the GM engine because it offers a lower total cost of ownership over a 10-year life cycle. Fewer cam phaser replacements, fewer turbo failures, and reduced oil consumption issues. In comparison, Ford's EcoBoost V6 faces cam phaser failures around 60,000 miles and turbo replacements near 100,000 miles. Ram's Hemi suffers from inconsistent lifter longevity, a known lottery problem. GM's approach may be less exciting on paper, but in commercial use, it dominates. Reliability over peak numbers wins the long-term race, especially for $80,000 plus trucks. The one weakness, low-end torque. No engine is perfect. The L8T's main limitation is low-end torque, between 1,500 and 3,000 RPM. Ford's 7.3 liters produces approximately 30 more pound-feet than GM's 6.6 liters. And this difference is noticeable when towing a loaded trailer from a stop or climbing steep grades at low RPM. However, GM's lower torque at the bottom end is intentional. By using a shorter stroke and lower compression ratio, they reduce stress on the bottom end, prioritizing longevity over maximum low-end output. Ford and Ram may feel stronger initially, but sustained heavy use over hundreds of thousands of miles will stress their engines more severely. It's a calculated trade-off. GM sacrifices a bit of low RPM grunt to gain reliability measured in decades rather than miles. The verdict: who should buy? Which engine? Here's the final assessment. GM 6.6 liters L8T, ideal for those prioritizing long-term reliability, commercial fleets, or regular towing below maximum capacity. Longevity, total cost of ownership, and minimal maintenance are the primary benefits. This is the engine for a truck you plan to own for 10 plus years. Ford 7.3 liter Godzilla. Better if maximum low-end torque and towing capacity matter more than longevity. Suitable for short-term ownership, heavier towing, and buyers willing to accept higher maintenance costs. Ram 6.4 liter Hemi. Avoid until lifter issues are resolved. The risk of catastrophic early failures makes it unsuitable for long-term investment, especially for $80,000 trucks. In conclusion, GM didn't just make a reliable engine, they ended the V8 debate in 2026. Not by producing the highest horsepower, but by creating an engine designed to last, even under the harshest commercial conditions. The 6.6 liter L8T proves you don't need 500 horsepower to dominate the heavy-duty truck market. You need a power plant that's still running strong at 300,000 miles. Next steps and recommendations. For viewers who want to compare GM's naturally aspirated approach with Ford's pushrod 7.3 liter Godzilla, we have a full mechanical breakdown available. We analyze oiling systems, pushrod design, and real-world reliability metrics. Understanding these engineering details is crucial if you're serious about buying a truck for heavy-duty use or fleet operations. Remember, the best trucks aren't always the ones with the highest horsepower. They're the ones that keep running mile after mile, year after year, without breaking down. If you're getting value from this technical deep dive, hit subscribe for more mechanical truths and reliability insights in the SUV, American muscle, and luxury truck space. Like the video if you want more in-depth engine breakdowns, and leave a comment sharing your experience with these trucks. The best journeys start where the road ends, and understanding what's under the hood is the first step.